Hey guys, Dr. Callahan here. Welcome to Calculus AB for week 3 Friday. These are your three warm-up questions. Number one is, what are your plans for the weekend? If a tourist asks you what is fun in Reno, what would your response be? If given the chance to redo one thing this chance, I shouldn't say change, chance to redo one thing this year, what would it be? And the last one is factor the cubes using the formula. So a cubed minus 125 b cubed. So go ahead and take a moment and pause this video and do your warm up. All right, so let's go ahead and take a look at the stuff that we're doing today. So there are several resources that you guys can go ahead and use. One of which is your Wednesday assessments, where you guys have your AP College Board one. Well, we haven't actually had an assessment on there yet, but we will. You also have your quizzes on your Math Excel and then also paper pencil format. You guys do have your textbook. If you don't have a textbook, you can come see me, and if you want one, I will be more than happy to give you one and have you check it out. You can use my Dr. Callahan note packets that I give you guys every single week, your Math Excel, your Google Doc of skills that's created by me, Alper.io, which we haven't started yet, but I will share that with you. You guys actually have a page that does have the code to it from the previous week, and then also Khan Academy Calculus. So looking at this part right here, I want to go ahead and take this and I want to write it in a way that it is cubed. So I can say a cubed minus 5b cubed, which is equal to, if you look at, this is the formula. So my x is going to be a and my y is 5b. So just fill it out. So it is going to equal to a minus y, which is 5b, times x squared, which is a squared, plus x times y, which is going to be a 5ab, plus y squared, so that's 25b squared. And that is your answer. Last time I saw you guys, I gave you guys 6 different examples on limits. And so I have the answers right here. So take a moment to go ahead and check your answers. And I'll just highlight them for you as well. So pause it. Here's number 2 and number 4. This is actually my graph. Your graph can look a little bit different than mine. This is number 4, and again, this is my graph. So for number 3 and number 4, they may vary depending on how you drew them. But as long as these limits were met, you should be good. And number 6 and number 8, all right, let's go and take a look at what we're going to be doing today. So today we're going to talk about the third part of limits, which is how to find limits analytically, which is using algebra. So we're going to look at properties of limits and strategies to find limits. I have 3 practice questions for you guys at the end. There is a Quizlet. Here's a link. And extra practice for week 3 Friday guided notes. You can use your desk for that, or you can do this at home, of course. So let's go ahead and take a look at our notes for today. So in your packet, I realized that there was a little of an issue with the copier. It actually eliminated some of the pages. So you guys only have like week 3 Tuesday, and then skips over to week 4 Thursday. So when I see you guys in class, I'll give you guys the missing papers that you need for that. So don't worry about that. So here it is. This is what you guys have for the first page of week 3 Friday. There's some extra examples of practice. Make sure you guys read this document right here, and I always label them. So this is week 3 Friday. Make sure you guys go over my written notes, and these are my written notes of things from the textbook, so that way you guys don't have to copy it down, but just go over the theorems. And let's go ahead and get started with this. Your guided notes is going to start right here. So on this page, we're going to go over example 3, 6, 7, and 8. All right, so there are 3 different ways of finding a limit. The first way, as we went over, is by using a table. The second one is with a device graphically, and the last one is using algebra. So let's take a look at example 3. So if I use direct substitution and I put 1 in there, 1 plus 1 is going to give me a 2. And guess what? It doesn't give you an undefined because it doesn't give you a 0 in the denominator, which is awesome. So then what I can do with this is I'm just going to put 1 on all of them. So I have 1 squared plus 1 plus 2 over 1 plus 1. So my answer will be a 4 over 2. And my limit as x approaches 1 will give me the function of 2, or y equals 2. Now let's take a look at this example. What if, for example, instead of using a 1, I can also use something that's close to 1. So as x approaches 1 from the left side, I can use 0.999, or as x approaches 1 from the right side, I can use 1.0001. And if you plug those into the calculator, your answer will also give you a 2, or actually something that's very close to 2, like 1.999 or 2.001. There are 2 common things when you will end up with undefined. The first one is a fraction. If I have x equals -1 right here, a -1 plus 1 will result in a 0. The other one is going to be a square root. You can not have any negative numbers in the square root because it will give you an undefined as well. All right, example 2. So x approaches 2 for 4x squared plus 3. I can go ahead and use direct substitution, so let's go ahead and try that. If I were to go ahead and use direct substitution, I will go ahead and replace everything that has a x with a 2. So then I have 4 times 2 squared plus 3 equals 19, which is then going to give me 4 times 4 plus 3, which is a 16 plus 3, and my answer is a 19. Let's take a look at this right here, okay? I know it's a little bit blurry, so I apologize for that. As x approaches -3 for this one, you know you're not gonna get undefined because it's not a fraction, it's not a square root. So 2 times -3 squared plus 4 times -3 plus 1 is gonna give you a 2 times -3 squared. Remember, this is a negative number with an even exponent, so it's gonna give you a positive 9 minus 12 plus 1. So 18 minus 12 plus 1 is going to give you a 6 plus 1, which is just a 7. Similarly, over here, as x approaches 1, you will have a 1 minus 3 on top, 1 squared plus 4, which is going to give you a -2 over a 1 plus 4, which is a -2 over a 5. And that is your answer. Now let's go ahead and get to something like this, okay? For example 6, if you use direct substitution, okay, DS for direct substitution, 1 minus 1 gives you a 0 in the denominator. So, oh my gosh, cannot do that because it's going to be undefined. So does that mean your limit is undefined? No, it just means that you have to be a little bit more creative with your algebra. So looking at the numerator, I know this is the same thing as x cubed minus 1 cubed. So I can use a cube factorization to go ahead and rewrite the numerator. So it's x cubed minus 1, so I'm going to be using this formula right here. So I can say as the limit x approaches 1, on top, I'm going to rewrite it as x minus 1 times x squared plus 1x plus 1. And on the bottom, x minus 1. What do you notice on top and bottom that you can cancel? X minus 1 is gone. So now with the denominator being eliminated, you can now use direct substitution, and you just take the 1 and then apply it into the numerator, which is going to give you a 1 squared plus 1 plus 1. So your answer is going to be 3 and not undefined. And that is using limits or finding limits analytically. Okay, let's take a look at example 7. As you know, direct substitution does fail. So then what does that mean? That means I will have to factor the top. So if I go ahead and factor the top, you ask yourself, what times what gives me a negative 6? But okay, and my pen's not working. That's okay. But when you add it together, it gives me a positive 1. That will be x minus 2, x plus 3 over x plus 3. So the x plus 3 cancels, and you have x minus 2 as a result. So you plug in the negative 3. Negative 3 minus 2 will give you a negative 5. All right, you guys, take a moment to pause the video to go ahead and work on this example. You have A, B, and C. My answers are given to you right there. Let's see if you're able to find them. And here are my steps for that. Okay, so let's go ahead and take a look at this one here. Now this one you have a square root, and it is actually called a conjugate. So my pen is not working, but that's okay. I'm just gonna go over it with you guys. So if I use direct substitution, x is 0, so that would result in a 0 in the denominator, so that would not work. So what do you do in this case? You use the conjugate. This is something that's going back to Algebra 2 honors. So what is the conjugate of the numerator? Square root of x plus 1 minus 1, the conjugate of that is going to be a plus 1. So if I multiply the top by the conjugate of square root of x plus 1 plus 1, I have to do the same thing on the bottom because you can multiply anything by 1, right? So then in which case, in the top, you will have to do FOIL, unfortunately. So I'm going to set it up as FOI on the side. First is square root of x times square root of x. Well, the double square root cancels, and you just have x plus 1. Outer, so this is on the outside. 1 times square root of x is going to give you 1 square root of x. Then inside is negative 1 times square root of x is negative 1 square root of x plus 1. And then last, negative 1 times positive 1 is going to give you a negative 1. Notice that your outer and inner cancels because it's a positive and a negative. So then you have left, and what's remaining, x plus 1 minus 1, positive negative 1 cancels, and you just have x. So then with that said, you have x on top in the numerator. In the denominator, you have x times square root of x plus 1 plus 1. And lucky for you, the x's cancel. So you have a 1 in the numerator that's remaining. Square root of x plus 1 plus 1 in the denominator. Now you can do direct substitution without resulting in a 0. So 0, replace the x here. So 0 plus 1 is a square root of 1, which is just 1. 1 plus 1 is going to give you a 2 in the denominator. So your answer is 1 over 2. All right, you guys, I'm going to go ahead and end this for today. I will see you guys next time. Take care.